All right. Okay, so Irene is here. Right. Okay, come, let's continue. And then you look at the object B, it says it's copper. So the answer came out. Okay. And then C is glass. So this is actually glass. And then D is iron. So when you are looking at this, you have to think about which are the conductors, which are the insulators. So we already know that these are the conductors, right? I use a C to represent this. And then glass is actually insulator. So if let's say this is the insulator, right? No current can flow through it. Therefore, R is unlit. Okay, so electricity cannot pass through R. There is no complete circuit. Yeah? Okay. So answer is A. Next one. Okay, these following electric circuits consist of identical bulbs. We completed this, isn't it? And we talk about the torch. You were playing with torch. You put the batteries in the different direction. Right now, Wheeler played with torch before, right? I remember last week you were nodding. Oh, yeah, you did that. Okay, so we already found out the answer here. Okay, because we have many questions. I'm not going to repeat this part. Yeah, so this part we've gone through. We know that it is A only. So what did we do? We used the app last week to find out how the arrangement of the batteries actually affected the electrical flow. And I taught you extra things also, right? Remember about the cancelling out? Okay, if you recall. Yeah, so if you put the negative terminal, all right, joined to the negative terminal of another battery. Okay, so both batteries will cancel out. There's no current flowing. But if you add in one more battery, okay, current can flow again, but using only one battery's power. Can you understand? Huh? Question 3. So study the circuit diagram below carefully. Which of the bulbs in the circuit will remain lit when bulb X has fused? So this one has fused, meaning it is no longer working. If it's fused, that means the filament already is fused, right? And then it's an open circuit. There's a gap. Electricity cannot flow. So this is the part. Electricity cannot flow. So remember parallel circuit, right? I have shown you before. Okay. So this is one possible path for current to flow. Agree? There's one more path because it is parallel. The next path that it can flow is actually this one. This way. Yep, so there are two separate paths for the electric current to flow. Okay, Wheeler, recall this? Yeah? Kennis, can you remember this part? We talk about parallel circuit. There's more than one path. We played the Kahoot, remember or not? Then you are supposed to choose, okay, and then you choose the wrong answer. Yeah, so you have to be very careful when the bulbs are connected in parallel. Electric current has more than one path to flow through. Okay, so each of this path, right? Okay, look at the first one here, purple line. Can you see that there's a gap in that particular circuit? So current cannot flow. Next one, the blue line, showing you the second path that electric current should be flowing, but because of bulb X, right, being fused, current cannot flow. There's a gap there, right? There's a gap there. So which bulbs can light up? None of them. Good, Wheeler. Thank you. Okay, so none of them because current can't flow at all, right? So for the new students, you don't have these questions, right? Correct or not? Don't worry. When we go to worksheet 16, you'll be able to see. You just watch the lesson. You can take screenshot if you want to. All right, it's fine, but I will suggest you pay attention because once you sign up, you can see all these anyway. Okay? Yeah. Right, so this particular question now, question 4, diagram below shows a closed electric circuit. The bulb in the circuit lights up. It will go off only when the dry cell is flat. So when the dry cell is flat, then the light will go off. Imagine this is your room. Okay, you can't turn off the lights at all. You have to wait for the electric or all the electricity to be totally used up. So can you sleep properly at night? You can't. So what must you do? What must you do so that you can control the lighting? Okay, what must you do? Yes, have that switch. Yeah, thank you. So you connect a switch to the circuit. All right, so when you connect the switch, right, what happens is you will have something like this in the circuit. Those who have not learned, right, you might not know that this is actually the symbol. Okay, so usually we draw a straight line lah. Yeah, but I cannot have two lines for the circuit, right? Okay, so if it's open, okay, this will be like that. If it's closed, that means the line is just here. So it's closed. Okay, the usual switch, we draw this way. Okay, not so straight. We draw this way. And then this is the wire connecting to other parts of the electric circuit. So this is an open circuit, okay? And then this is a closed circuit. Electric current can flow, all right? Next, question 5. Study the circuit diagram below carefully. When bars A, B, and C are connected to the circuit below, only bulbs 1 and 2 light up. Okay, so what can you conclude from the observation? So when they are connected, only 1 and 2 will light up. Okay, that means that the third one there, all right, doesn't light up. So what can you say? Okay, is it that bulb 2 has fused? If bulb 2 has fused, can it even light up? No. Okay, so this is not true. Bars A and C are magnetic objects. Magnetic objects doesn't tell us much, isn't it? Okay, it doesn't tell us much. Yeah. So A and B conduct electricity. Do you think that's correct? A and B, yes, very good. So A and B conducts electricity. So current can flow. Okay, just a minute. I see somebody text me something. Oh, Irene, you text you actually put in the answer. Yes, correct. Kenny's, be very careful. Remember I told you about, okay, Kenny's was sharing this with me. I thought we should just talk about this. She went to the science lab, okay, last Thursday with her science teacher. All right, so the whole class went there and then they connected the battery together with light bulb, and the switches, okay, using the wires. So when the light bulb lights up, okay, she was curious. So she went to touch the light bulb. And then she felt that it's so hot. How many of you have done that in school? I did when I was young. I like to touch everything, Sometimes I play around with the battery and the wire and it seems like there's a little bit of shock. Okay, I get some pain in my fingers. Why? Because the current is flowing. You're not supposed to touch the wire with your bare hands. Okay, don't play with it. Okay, thank you for sharing. Now, be very careful. You know why the light bulb actually lights up? Have I shared with you? I think I did. Because the filament starts glowing, right? Because the current flows through that filament in the light bulb. Okay. Do you still remember how the light bulb looks like? Okay, if I try to draw, okay, my drawing might not be perfect. Okay, but you have something like that. And then this is the metal casing. And then there's a metal tip. Then you have the glass. And over here, you have something here, right? Like this. Quite nice, actually. So this is the filament. When the current flows through, all right? When the current flows through the filament, it gets so hot. It gets so hot that it becomes red hot. Yeah. Okay, when it's red hot, right? It starts glowing more. And that's how we get light. That is how the light bulb actually works. Okay, because the filament was glowing. Now it's so hot, even though like, it's quite far away from this glass. If you touch the glass, it's going to be very, very hot. Have you ever tried, let's say, changing light bulbs at home? Not you, maybe your father. Yeah, and then he takes it down. He said, don't touch it, it's hot. Right or not? Okay, do you all any ways to go and touch it a little bit? I mean, I did, and it was very hot. Yeah, Irene did also. Okay, I was a curious child. I'm still curious. Okay, so generally very curious person lah. I will dismantle things just to see what's on the inside, stuff like that. I mean, it's fun, right? Like the watch, right? If it's spoiled already, I'll just unscrew and open up and see what is inside. Then my dad will be saying, yeah, we can send for repair. When you open up, you take out anything, we can't send it for repair anymore. And then my dad will tell me things like that. Jiaqi, when you put out your hand, you wanted to share something?
Yeah, I go to the toilet.
Oh, yes, please go. Remember, just type in. Okay, just type in the chat. Let me know you are going to the toilet and immediately you should go. Please do not sit and wait for me to give you the permission. If I don't see your message, then you have to tahan for too long. Not so good for your bladder. Okay, you just go. It's important. All right, so where was I? Okay, so do not touch any light bulbs with your bare hands, especially when it's turned on for some time. Now, Kenny, you were sharing that your friend's light bulb was not hot, but it was lit. Okay, there are different forms of light bulbs. Can you go and check whether they are exactly the same or is it from different brand? Different brand actually will be slightly different. Okay, it could be the LED. It could be the usual kind of light bulb. So you go and check. All right, Kenny's. So the old type, where's my light bulb? Supposed to be here on my table. Okay, things kept. Okay, never mind. All right, I can show you some examples next week, okay, of the different light bulbs I have at home, right? So over here, the answer is actually bars A and B conduct electricity. Of course they must. Otherwise, electric current cannot flow through them. Okay, A and C do not conduct. That's not true. If A and C do not conduct, right, okay, every bulb will not light up. Okay, so answer is C over here. Okay, before I let you tell me your answer, or before I explain to you on this part, take a look at this video. Okay, I'm going to share the screen now. Can you see this? Okay, can I? Right, so I'll play this. Okay, hold on, then you give me 1 minute. Let me try to do something to make it better. Yeah, thank you. Because I see that y'all are actually telling me it's very laggy, it's very laggy. Your response will help me to know all this. Thank you. Hold on. How many of you have tried this in school? Okay, I saw Jia En put out a hand. Kenny's typed just now to let me know. Okay, yeah. So good. If you have tried this, wonderful. I will just quickly do this. Give me a few minutes. See whether this works. My internet connection is actually at full blast. My Wi-Fi is working. Can you check your connection also? Are you able to check? Because mine is actually very good. The rest of you all okay? All full bar. Oh, Wei Le says it's full bar. Wei Le for sure lah. Okay, Wei Le, when you play Kahoot, I know already. Wei Le play Kahoot, he's always, at the top. Yeah, and we are wondering, how come he's always at the top? Then I realize, it's the Wi-Fi. Okay, let me try this. I hope this is better. Okay, I'm going to show you now and you let me know if it's better. Right, but anyway, okay, you understand the logic of this circuit card. So long as there is a closed circuit, current can flow. Poor thing, Kenny, don't worry. I will send you the link to that YouTube video. Okay, and you can watch it later. Not now, but later. Is that all right? Okay, I'll send it to you end of class better. If I send it to you now, you will start watching it. Okay.